Hello everyone, so let's move on to our next topic, that is preparation and physical properties of glucose. So first of all, I want to talk about the preparation of glucose, then I want to talk about the physical properties of glucose. Okay, so as far as preparation is concerned, so glucose is produced commercially or prepared commercially by hydrolysis of a starch with dilute hydrochloric acid at high temperature under pressure. So what does this actually mean? First of all, I'm going to write down how glucose is produced, then I'm going to introduce you to the chemical reaction. Okay, so I'm going to write down glucose is produced. Here, produced and prepared both are the same thing. You just have to understand how it is produced commercially. Commercially means on the commercial scale by hydrolysis. What is the meaning of hydrolysis? You already know, breaking it down using water. Okay, hydrolysis of a starch. So we are going to hydrolyze a starch. Okay, with dilute hydrochloric acid. Hydrochloric acid, that is HCl. Okay, with dilute hydrochloric acid at high temperature under pressure. High temperature under pressure. Under pressure. So this is how glucose is produced. So what does this say? Is then let me introduce you to the chemical reaction. First of all, I'm gonna take a starch. Okay, so it's gonna be C6H10O5 whole N. So this particular molecule is a starch molecule. In polysaccharide, you have already studied about starch, that it's a kind of polymer of glucose, in which are from 300 to 1000 glucose monomers are found. So this is the starch, and this is the formula of a starch. And if you're going to hydrolyze it, hydrolyze means breaking it down using water. So I'm going to react it with water in presence of hydrochloric acid, that is HCl, that is uh, dilute hydrochloric acid. Okay, I'm gonna hydrolyze it. That means I'm gonna react it with water, and as a result of this particular reaction, what's gonna happen is that glucose n number of C6H12O6 will be formed, and this will be called as glucose. Glucose. So I hope this point is clear right now. So to produce glucose on commercial scale, first of all, what you're going to have to do is that you're going to have to hydrolyze starch, because starch is the polymer of glucose, and in starch from 300 to 1000 glucose monomers are found. So you're going to hydrolyze it in presence of dilute hydrochloric acid, and glucose molecules will be produced. Okay, so this was about the preparation of glucose. And now what we are going to see is that we're going to take a look at the physical properties of glucose. Okay, so what are those physical properties of glucose? So I will write down physical properties of glucose. These are just important things to know, which you should know actually. So one by one I'm going to write down what are those physical properties of glucose. Okay, so the first important property will be, it's a white crystalline solid. So glucose is a white crystalline solid. Crystalline solid. It's a white crystalline solid. And number two, the physical properties of glucose will be that melting point is going to be 146 degrees Celsius. That means if you're going to try to melt, if you will try to melt glucose, then you'll have to heat it up to 143 degrees Celsius, and then when the temperature will reach 146 degrees Celsius, glucose is going to get converted into the liquid form. Okay, and after that, number third physical property is going to be it's extremely soluble in water. Extremely soluble in water. As you already know that if you have glucon D, that is D plus glucose in your home, which you sometimes drink whenever you go to play sport or whenever you go outside for running or jogging, you can see that it's extremely soluble. Whenever you dissolve it in water, you don't have to even stir it. It's gonna dissolve inside of it. So that is extremely soluble in water. Okay, and number four is going to be sparingly soluble in ethanol. Sparingly soluble. That means it definitely dissolves inside of the ethanol, but not that fast, or not at the extent at which it dissolves inside of the water. So that you have to remember. And number fifth is gonna be insoluble in ether. It's definitely not gonna soluble in ether. And number six is going to be optically active. Optically active, that means it has capacity to rotate the plane of polarized light either into left or right direction. That it is optically active. So definitely it has some optical properties. And then as you have already seen that glucose was rotating the plane of polarized light into the right direction, that's why it was plus glucose. And then number 7 is gonna be so ordinary naturally occurring form is plus glucose. As I already told you, ordinary naturally occurring form is plus glucose. Why this is plus glucose? Because the ordinary form of glucose, which is generally found inside the nature, rotates the plane of polarized light into the right direction. That's why. Okay, and number 8 is gonna be about 3/4 as sweet as sugar cane. So glucose is gonna be about 3/4 as sweet as cane sugar. Okay, and then number 9 is gonna be when crystallized from cold water it forms glucose monohydrate. Okay, so when from cold water it forms glucose monohydrate. So you'll have to keep it in mind that if if the glucose will be crystallized from the cold water, the process of crystallization you can just take a look at in the like basic organic chemistry which you study in the high school. But here I'm gonna discuss about it, that when it will be crystallized from cold water, it forms glucose monohydrate, and the formula of glucose monohydrate is gonna be C6S12O6 S2O. So this is the crystallized, when glucose monohydrate is formed, when glucose is being crystallized from cold water. So I hope this point is clear right now. So these are the important, physical properties of glucose. It's basically a white. I was going to write on white over here. It's a white crystalline. It's a white crystalline solid.